incorporated in our definition of intelligence, and rather what I've seen happening, at least in the things I'm aware of, is we pick specific tasks, and hopefully those together will make a more intelligent hybrid system.
So before coming to SAIC, you predicted what's going to happen. You know, you imagine something. You know, you imagine the experience of being at SAIC. How was it similar? How was it different? After having conversation with the artists and designers and architects and.
So it's definitely been very different. So I came from an engineering background, more or less, engineering and math. And what I love about it is people are very open in their thinking, and they're ready to try new things, and they're ready to try big things. So in my class, I have people working on amazing projects, like things like a translator from English to Yoda. Yeah, using an HMM and all this complicated stuff, but they're doing it. Chatbots that are trained on real people. How to link up discourse and things. So I've been very excited because it's sort of a chance to, typically in engineering the way it works is you pick a problem which everyone else is working on and you try to get plus 2% performance or something. It's hard to define a new problem and get a lot of people to work on it. Whereas I think, at least my impression so far has been that there's more of a willingness to do that here, and there's more of a willingness to go out and do the effort to gather the data you need because you have to gather data. And maybe it's actually to your benefit to go work on a new problem. So that means it's changed the way I teach my class. We're more open. We get to define our own problems and brainstorm about how to solve them. You have to think of, how are we going to get any information that will help us here? It's changed the way that I think about teaching programming, where maybe you don't have to learn you don't have to learn precise algorithms if you're able to get help from people or get help from the internet, that kind of thing. It's more important to learn how to synthesize existing pieces of code, which is how we work in practice. So it's been a good experience too, and something really funny happens as a result is you end up doing more science. Because if we work on it, if I were in a class where we're going to work on the handwritten digit recognition, there's an existing data set, people have used existing features, you can go read the best papers and try to improve over that. That would be a great challenge. Whereas here, when you pick a new problem, if you're going to speak Yoda, no one's tried to do that before. And it's hard, because there's not much training data out there. And some of it's kind of suspicious. It might have been written by different people. It might not be an actual language. So there's new challenges because it means you have to think like a scientist, which is you have to think like, okay, where am I going to get the data? How am I going to evaluate? And you have to do some of that exploratory work that you don't necessarily always do in an engineering class.